So this week, a lot of exciting updates on the RF glow sticks. Made a lot of progress on learning how to do resin casting. And so this is the first week actually that my test sticks here are actually completely homemade, meaning there are no stock King Blade parts on these. The diffusers, this one is the resin cast diffuser, and the other diffuser is the SLS printed one, the one that I had professionally printed some weeks ago. This is also the new version of the handle where and PCB, where the switch and a push button have been added to the front here, and this gives us access to the power switch now without having to crack open the case. So the only reason why I need to open the case now is to, which I can, as always, I just kind of put it in half here, is to replace the battery. The case has some changes. There are now these pockets here, and these pockets are to hold magnets, which I have a pile of magnets here. So with these little magnets I've got here, I'll be able to put magnets in here and have the two halves of the case held together magnetically. It turns out right now I don't really need that level of security because the tension of the case actually is quite good. All right. This edition of the case also has the button added. So we've got the button here. The button isn't coded to do anything right now. It's hooked up to one of the digital inputs with the click button controller. I would be able to, or with a click button Arduino library rather, I'd be able to make this do something like change the colors or something. Right now it doesn't do anything. So I'm going to go ahead and take these two, and now that I can, turn them on, right? I'm going to leave them here for the moment so that we can see them in action. By default, they'll be off. Let me move this so we don't have so much glare. Also new this week is the Bluetooth LE based master. And this is a very, very exciting development here, the Bluetooth. What I can do now is, this is a pan stamp, this is the antenna, this is the Adafruit NRF 8001 Bluetooth LE SPI breakout board. And this is a board that I made through isolation routing on a shopbot that I ran off at the tech shop last weekend. In general, I don't recommend doing isolation routing. It's very fast. So I don't have to wait for the turnaround time, but it's really quite difficult to solder stuff onto this isolation routed board. The amount of copper is just tremendous, and you put tons of heat on the pin. So if you look at this breakout board, actually, let me turn it off momentarily, you'll see that there's this power supply here. I burned out two of these power supplies trying to solder it in before I switched and first soldered in the jack here, the female header, and then putting the 3.3 volt regulator onto the female header. So this is pretty annoying, but it was good for running this off over the weekend. Otherwise, I would have had to wait 2 weeks for Seed Studio or something to do it, and so that was good. I've got a power switch run into it, and then I've got the 9 volt battery. The draw from this total setup actually is very, very low. It doesn't really use much power at all. Uses maybe about, measured from this battery, you'll see here that this says it's a 600 milliamp 9 volt battery. It pulls around 10, 11 milliamps while it's transmitting, which is not much at all. Right? There's like 50 some hours of transmission time. And with the Bluetooth LE, I no longer have to worry about futzing around with switches and updating the Arduino code for switches like I had in the previous in the previous board here. Instead, I can focus on software-based controllers in an app development environment instead, and then you could tuck this, in a bag or under the seat. The range of the Bluetooth LE is pretty good, right? If it's under the seat you're sitting on, or if it's in your pocket or something, clipped to your waist, it's totally close enough to meet your iPhone or Android device. And so to demonstrate today, I'm going to turn it on with this power switch. There's no indicators or anything, so I'm just going to have to sit it right over here. And then I've got my iPad over here. So on the iPad over here, I've got TechBasic. Let me get this out of the way now so you can see a little more clearly. I've got TechBasic here. TechBasic allows me to do development on the iPad itself for rapidly iterating the protocol, and it allows me to access the Bluetooth LE APIs. So I'll go into TechBasic, I can head over into my programs here, into my RF Glow BLE control, and you'll see that the connection speed on BLE is super fast. It's not like this old school Bluetooth, right? You'll notice that as soon as I launched it, it goes attempting to connect to RF Glow, and what it did there was it was searching for any Bluetooth LE devices with the service UUID, and it found the service and found the characteristic, right? And this happened insanely fast, right? So you don't really need to worry too much about pairing or anything. You just launch it and it goes, right? And this currently is a kind of a console, a standard in, standard out based application, but the TechBasic is capable of GUIs, and so I could tie these sending commands into the GUI event handlers. The interface here is very similar to the serial interface I wrote, since this is just for development purposes. You enter in 3 digits hue value, 0 on a 0 to 360 or 359 degree scale. 0 is red. The saturation from 0 to 255, and the brightness, which is from also 0 to 255. I'll hit 40 here. Actually, I want to do 64. And so this should give me red, right? And then I'm on a 0 to 360 color wheel. So if I go 60 degrees over, 60, 255, 64, right? Now I've got green, and I go 120, 255, or sorry, that's not green, that's yellow. 120, 255, 64. Now I've got green, right? Add another 60 to that. 180, 255, 64, right? And now I've got, blue green, go up to 240, 255, 64. Right, now I've got blue. So I can do this, and I could do fading by putting this in a loop, right? There's lots of things I can do now that I've got control from the app. I can build all kinds of applications using touch-based buttons and not have to worry about physical implementation of the system. 0, 0, 0, zeroes it out. The overall, the source code here, and really the way that the API stack works is very similar to the way that it works in real iOS. It's just that the iOS Xcode simulator for the simulator and Xcode for iOS rather does not simulate the Bluetooth stack. So I would have to upload it, compile and upload to the iPhone every single time. So when I iterate on, what is the right speed for me to send commands, so I don't overwhelm the modem, right? Because the modem runs at 9600 BPS. Bluetooth is about 3 megabits per second. So the Bluetooth interface is way faster than the serial modem. Serial modem right now I've tuned so it's like a 5-bit payload size. So it takes about a 30th of a second to send. So there are some timings that I have to work out. It's easier to work those out I have to work them out with the real devices, it's easier for me to iterate here in TechBasic. But the principles and the APIs are very similar. I start the scanning for the UUID here, and then there's a series of different callbacks here to handle the different events that you have to implement. And then there's the overall event here that I'm using to run the null event. Basically, it's called when there's nothing else going on. And I use this to handle the standard input, the text-based input. So that's pretty much it for this week. This also probably represents most of the end of what I need to do for the embedded development. Now that I have this Uber Bluetooth low energy board, I can really complete my controller development entirely in an app. Eventually, right, I can get it onto like this iPhone here, and then with an armband or something, you could strap this to your arm. Especially if you have bigger arms than mine. My arm's a little small for this, but it'll still fit, right? And then you'd be able to control the glow sticks on kind of an easy to use interface with all kinds of UI features.